All right, this is Unit 1 on solving equations and inequalities. So Lesson 1 is all about operations of real numbers. So Lesson 1, operations on real numbers. My lesson essential question is, how can you classify the results of operations on real numbers? At the end of this lesson, you'll be able to reason about operations on real numbers. All right, example 1, understand sets and subsets. So in the set of numbers from 1 to 10, which elements are in both the subset of even numbers and the subset of multiples of 5? So first, a set is a collection of objects such as numbers. An element of a set is an object that's in that set. So I write a set by listing the elements enclosed in curly braces. Or brackets. So these like little curly braces. So name of the set is A in this case. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are all the individual elements in the set. A set B is a subset of set A if each element of B is also an element of A. So in B, those are the evens that are in that set. So 2, 4, 6, 8, 10. Okay. And C is the subset of A where the elements are multiples of 5, 5 and 10. So the only number that appears in all three of these is 10. So number 10 is the only number that is an element of both subsets. All right, so let's try it out. Which numbers in set A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are elements in both the subset of odd numbers and the subsets of multiples of 3? So let's say B is my subset of odd numbers. So in this case, my odd numbers are 1, 3, 5, 7, and 9. Okay. And we'll say C is my subset of multiples of 3. So that's 3, 6, 9. Okay. The two numbers that are in all three sets are 3 and 9. So 3 and 9 are my answers. All right, example 2, compare and order real numbers. Jim is playing a math game where he needs to put a set of 3 cards in numerical order. His cards show 40 over 11, the square root of 324 over 36, and the square root of 10. Order the cards from least to greatest. So I find the decimal equivalent for each number. So I get 3.63 repeating, 18 over 6 or 3, and 3.2. I can plot those points on the number line. So from least to greatest, or smallest to largest, I get the square root of 324 over 36, square root of 10, and then 40 over 11. All right, so let's go ahead and order each set of cards from least to greatest. I have 0.25, square root of 1 over 9, and 6 over 25. So I'm going to go ahead and put these in decimal forms. 0.25 is already in decimal form. So the square root of 1/9 is 0.3 repeating, and then 6/25 was 0.24. So the smallest of these is the 6/25. Okay, then I have the square root of 1/9. Oh no, I have 0.25, and then I have the square root of 1/9 because that's 0.33. Okay, I do the same thing here. Square root of 121 over 25 equals 11 over 5, which is 2.2. 2.25 I don't have to do anything with, and then the square root of 5 is approximately 2.236. So again, I'm going from smallest to largest. So I have 2.2, which is like 2.20, okay, 2.25 and 2.23. So the smallest one is going to be the square root of 121 over 25. That's the 2.20, and then 2.23 is the next, so the square root of 5, and then 2.25 is my last. All right, example number 3, operations with rational numbers. Is the sum of two rational numbers always a rational number? So you can try several different cases of adding two rational numbers together. 1/2 plus 1/3 equals 5/6. 7/8 plus 3/4 is 13/8. 11/5 plus 1/6 is 71/30. In each case, the sum is also rational, but you cannot try every pair of rational numbers since there are infinitely many of them. How can you know whether it's true for all rational numbers? I can use variables to represent any rational number. So A, B, C, and D are integers where B cannot equal 0 and D cannot equal 0. Because if B or D equals 0, bad things happen in the universe. You cannot divide by 0, okay? So AB plus CD is AD over BD plus BC over BD. Okay, so basically what we did here is I multiplied this by D and this by B. So this by D and this by B, so I could have a common denominator. So I get AD plus BC over BD. Again, B can't be 0, D can't be 0, so BD also can't be 0. Since AD plus BC and BD are integers and BD can't equal 0, the sum is rational. So is the product of two rational numbers always a rational number? I use the same strategy as in part A, using variables to represent any rational number. A, B, C, and D are integers with B and D not able to be 0. So I multiply AC equals BD. So since B can't be 0 and D can't be 0, BD also can't be 0. Since AC and BD are integers and BD is not 0, the product is rational. All right, so let's try it out. Is the quotient of two rational numbers always a rational number? Explain. Okay, so using the same type of logic, yes. The quotient of two rational numbers, AB divided by CD, is AD over BC, which is a rational number. If A equals 0, then the quotient is also 0. 0 is a rational number. Values of B, C, and D cannot be 0 because you cannot divide by 0. All right, example 4, operations with rational and irrational numbers.
Is the sum of a rational number and an irrational number a rational or irrational number? Write the sum of an irrational number and a rational number as a rational number. Every rational number can be written as an integer divided by a non-zero integer. So for A divided by B and P divided by Q to be rational, A, B, P, and Q are integers with B and Q not equal to 0. Solve the equation for C. First, subtract A divided by B from both sides of the equation. The equation becomes C equals P divided by Q minus A divided by B. Write the right side of the equation with a common denominator. The equation becomes C equals P times B minus A times Q divided by B times Q. In the equation, the numerator is an integer because it is a combination of integers by multiplication and subtraction. So P times B minus A times Q is an integer, and B times Q is an integer not equal to 0. Therefore, P times B minus A times Q divided by B times Q is a rational number. This is equal to C. But from the given statement, C is an irrational number. But this is a false statement. A number cannot be both rational and irrational. So what went wrong? The mistake was to assume that you could write the sum a divided by b plus c in the form p divided by q in the first place. Therefore, the other choice, the sum must be irrational, had to be true. The sum of a rational number and an irrational number is always an irrational number. Is the product of a rational number and an irrational number rational or irrational? Write the product of a rational number and an irrational number as a rational number. By definition of a rational number, a, b, p, and q are integers, with b and q not equal to 0. Solve the equation for c. Multiply both sides of the equation by the reciprocal of a divided by b, or b divided by a. Since a times b times a equals 1, the equation simplifies to c equals p divided by q times b divided by a, or p times b divided by q times a. P, b, q, and a are integers. The product of two integers is an integer. So p times b is an integer and q times a is an integer. Because p times b is an integer and q times a is an integer, c is the ratio of two integers. So c is a rational number. Since we started with c as an irrational number, now c is both rational and irrational. So the assumption that you can write a divided by b times c as p divided by q at all is wrong. When you multiplied both sides of the equation by the reciprocal of a divided by b, you were dividing both sides by a and 1 divided by b. Also notice that in order to divide by a when calculating c, you have to assume that a is not equal to 0. If a equals 0, then a divided by b equals 0, and a divided by b times c equals 0 for any number c. So the product of a rational number and an irrational number is always irrational, unless the rational number in the product is 0.
All right, so let's try it. Is the difference of a rational number and an irrational number always irrational? Explain. So this is, yes, it is. So AB minus M. So let's suppose AB is a rational number, M is irrational. Okay, so there's my difference, it's subtraction. This equals AB minus EM over B equals A minus BM over B. Since M cannot be written as the ratio of two integers, A minus BM also cannot be written as the ratio of two integers. All right, so concept summary. Operations on real numbers. So in words, the sum of two rational numbers is always rational. The product of two rational numbers is always rational. While the sum of a rational number and an irrational number is always irrational, and the product of a non-zero rational number and an irrational number is always irrational. So sums, I can add 2 9s plus 4 6, find a common denominator, and add my numerators together. Products, I just multiply them. So in algebra, for sums, AB plus CD equals AD plus CB over BD. Products, AB times CD equals AC over BD. Okay. So for irrational, square root of 3 plus 1/3 is 3 square root of 3 plus 1 over 3. Use the same type of thing. The products of the square root of 3 times 1/3 is the square root of 3 over 3. So my sums are AB plus C cannot be P over Q when C is irrational, and AB times C cannot be P over Q when C is irrational. All right, so that is the end of Unit 1, Lesson 1.